Okay, so then I'm going to do problem 4. Maybe. Not in highlighter. Which has f of x is equal to x plus 1, x minus 3 over x minus 2 squared. Right? And so again, what kind of function is this? This is a rational function. It's the ratio of 2 polynomials. The domain here should be everything except 2, because that's where the denominator is 0. So the function is not defined at 2, and I expect all the derivatives to be undefined at 2, because in order for the derivative to exist, the function value has to exist. The end behavior, so the limit as x goes to infinity of x plus 1 here, right? And this I need probably in polynomial form to take this limit. Get x squared minus 2x minus 3 all over x squared minus 4x plus 4. And this is the limit as x goes to infinity. And I'm going to divide through by x squared. So I have 1 over x, I have 1 here, minus 2 over x minus 3 over x squared, all over 1 minus 4 over x plus 4 over x squared. And these limits here, I'm going to highlight them, here, 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 and here, all go to 0 as x goes to infinity. So this is just 1 over 1, which is 1. So this end behavior should be 1. This also means that there's a horizontal asymptote of 1 for this function. Okay. D is any asymptotes or holes. So again, in this, I'm going to rewrite the function. This is in factored form already. And I already identified where the function was not defined. Right? So it's not defined at 2, and then the question is that a vertical asymptote or hole? In this case, because the factor x minus 2 doesn't cancel with the numerator, fully cancel, then x is equal to 2 is a vertical asymptote. And then I found a horizontal asymptote of y is equal to 1 from part C, right? Okay. Okay, so then E intercepts, so I'm going to set this, the x-intercepts, set this function equal to 0. When I do that, and now I'm going to multiply both sides by this denominator. That cancels here on the left, and then on the right I still get 0. So I get x plus 1 times x minus 3 is 0. So x is negative 1 and 3 are my two intercepts. And then the y-intercept I plug 0 in, so f of 0. And in the top I get 1 times negative 3 over negative 2 squared. I believe is negative 3/4, I think. Is that okay? Okay. So those are my intercepts. F, intervals of increasing, decreasing. Okay. And I took the derivative offline, and I can show you those steps real quick. But the top or numerator is x plus 1 times x minus 3, which I thought of as x squared minus 2x minus 3. And the derivative of the top is just 2x minus 2 which I factored already here. Then the bottom of this is x minus 2 squared, and so the derivative of that is 2 times x minus 2, and that's in factored form. So then the derivative, f prime, should be 2 times x minus 1, the derivative of the top times the bottom, minus the derivative of the bottom times the top, which I'm going to leave, I think, in factored form. I'm going to just see what this looks like with all these factors. All over x minus 2 to the 4th power. Okay. Then I'm going to simplify and factor out common factors, which here are 2 and 1 copy of x minus 2. So I'm going to factor one of those out. Something is wrong here, though. Oh, I copied this wrong. Look right here. This should be x plus 1. Can we check that? I think that's right. Okay. So these are the things that factor 2 times x minus 2. And then what I'm left with is x minus 1 times x minus 2 in this first term. And then, let's see, a minus x plus 1 times x minus 3 in the second term. And that I'll get a quadratic and need to simplify those. But this x minus 2 will cancel with the denominator, so I'll do that. 2, and then this is x squared minus 3x plus 2 minus, and then I have an x squared. I have to remember to distribute this minus, but I'm going to do this all in one fell swoop because I can, I think. So it's a minus 3 plus 1 minus 2, but then this should be a plus 2, right, x. And then the negative 3, but it should be a plus 3 when I distribute the negative. All over x minus 2, and I canceled one of these, so that's 3. So f prime is 2, and then these x squareds cancel, and I think I get a negative x plus 5. X minus 2 cubed as this simplified form. Okay. So then the critical values here should be at x is equal to 5. That makes the function 0. And then at x is equal to 2, that makes the function undefined, right? So I set, to get 5, I set this 2 times x, negative x plus 5. I do the same thing that I just did for the intercepts, right? I multiply both sides by x minus 2, and I get 2x negative x plus 5 equal to 0. This means negative x plus 5 is 0, and this means 5 is x. And then the denominator being 0 causes a critical value too. Okay. So I have these two critical values, 2 and 5. And again, it splits my domain into 3 pieces. And I have to find this test point in each of them. So there's 0, I'll put 3, and I'll put 6. And I plug the test point into f prime. Okay, so and again, I'm going to plug it into the factored form and just think about what this is. So 0 makes the top positive and the bottom negative, because it's 0 minus 2 is negative and raised to the 3rd power is still negative. So I think this is negative. 3 is the top is positive and the bottom is positive. So this is positive. 6 means the top is negative and the bottom is positive. So I get a negative. So I think I have this. This value is undefined, so it can't be a max or a min. That the function is undefined at 2. But this one here should be a max. Okay, so I'll write these conclusions. F of x is decreasing on minus infinity to 2 union 5 to infinity. f of x, the original function, is increasing on 2 to 5. F of x has a local maximum of, and I need to find this, at x is equal to 5. So I need to plug x is equal to 5 into my original equation. So let me find f of 5 is 5 plus 1, which is 6, 5 minus 3, which is 2, over 5 minus 2, which is 3 squared, right? 12 over 9, which is 4/3. Is that right? Okay. Okay, so of 4/3, right there. Beautiful. Okay, so that should be all the information from the first derivative. G, concavity. So again, I did this derivative and I got, let's say, f. So f prime, again, is 2 times negative x plus 5 over x minus 2 cubed. And so then when I took the second derivative, I got oh, I remember, because this is a negative x, so the derivative here is negative 2 of the top times x minus 2 cubed minus, and the derivative of the bottom is 3 times x minus 2 squared, and then times the top, which is 2 times negative x plus 5, all over x minus 2 to the 6th power. Okay, and again, I'm going to factor this. So I have a 2 here, and I have an x minus 2, and that's squared, and I think that's all that's shared. So I'm going to factor out a 2. I'm going to leave the negative and get x minus 2 squared. So then what's left here is negative x minus 2 minus 3 times negative x plus 5 all over x minus 2 to the 6th. And again, these x minus 2's will cancel. So I'll get 2 times negative x plus 2 plus 3x minus 15 all over x minus 2, and I canceled, so that should be to the 4th power. So second derivative is 2, and then this is 2x minus 13, I believe, over x minus 2 to the 4th. And again, when you set this equal to 0, you should get x is equal to 13 halves. And then again, a critical value of 2 where the original function is undefined. That will be a critical value of every derivative of this function. Okay, so I'm going to set this up. 2 is here, and 13 halves is like, what, 6.5? So I'm going to, again, this is minus infinity to 2 to 13 halves, and 13 halves to infinity. And my test point in here, I'll pick 0. I'm going to pick 3. And out here, I think I'm just going to pick 20 for ease. And I'm going to plug in, again, to this factored form of the second derivative to see what the sign is, right? So f double prime of the test point. So when I plug in 0, now I'm having trouble reading this with the green. So when I plug in 0, I get negative, like a negative 13 times 2, but negative. And then in the denominator, first of all, let's recognize, do you see that 4th power in the denominator? So I'm going to make these fractions. The 4th power means whatever I plug in will be positive. So I'm not going to bother to even think about these numbers. The 4th power makes everything positive. Okay, so then I'm just going to think about them in the numerator. Okay, so now 3 in the numerator is, mostly it's the 6 minus 13, which is negative. And 20 is 40 minus 13, which is positive. So I think I get a negative, negative, positive. Okay? So this is concave down, concave down, concave up. I also have an inflection point right here where it changes concavity. So let me find f of 13 halves, which now I'm just going to do as 6.5 because, gracious, I do not want to be doing this 13 halves the whole way. So I'll plug that into the original function again, and so I'm going to get 6.5. It's 7.5 times 3.5 over 4.5 squared. I'm just going to plug that into my calculator. This is a 4.5, not 4.2. And I get 1.29. Let me just check that real quick. And really it should be like a 1.30. Okay. So now I have these conclusions. F of x is concave down on minus infinity to 2 union 2 to 13 halves. I cannot combine these two because f of x is not defined at 2. So I need to split them up. F of x is concave up on 13 halves to infinity. F of x has a point of inflection at 6.5, that's 13 halves, and 1.30. Okay. Is there anything else I know to be important for this class of functions? H? I don't think there's anything else. I think we covered everything. Again, I kind of know it's not symmetric because I found the x-intercepts and they weren't like symmetric about the y-axis, so that might be a thing to think about, but I already noticed that when I found the x-intercepts. The scale. So again, I'm going to write kind of these conclusions and try and think of this. So 1, x is equal to 2 is a vertical asymptote. And maybe I won't, maybe I'll write these in 2 because this is a t-table. I don't want to. So I have x equal to 2 as a vertical asymptote. X equal to 1 is a horizontal asymptote. My values here, I had x-intercepts of -1 and 3, right? And then the y-intercept was it -3/4? Am I remembering that right? Where is this problem? This is a long problem. Let me see. Horizontal asymptote, yeah. Yeah, -3/4. Okay, let me write that down. 0, -3/4. And then I'm going to write down here where it's increasing and decreasing from that part so I can kind of check it. So forgive me for like scrolling up and down and up and down. Okay, so decreasing on minus infinity to 2 and 5 to infinity. I'm going to get a little bit bigger. Okay. Okay, and then on this middle from 2 to 5, it's increasing. And then there should be a max in here. Is there a max? Yeah, right. Max of 5 4/3. So 5 4/3 is my max, right? And then this concavity, so concave down. Now, I just want to be clear, like, you need to write sentences underneath these parts. Like, this is just me writing shorthand to myself so that I can kind of draw this graph and have all the information here. And this 6.5, 1.3 is a point of inflection, right? Okay, so again, when I'm making these decisions for I, I'm looking primarily at the numbers involved because I need all of this information to be on my graph. So the largest, I mean, I have an x value of 6.5 that is important. That's my point of inflection. So I need to make sure I go there. In other ways, my y values aren't that large, so I'm just going to kind of draw it. Like this. And again, I'm pretty picky. You have to label graphs so I can read them off the graph and not, like, I'm not counting tick marks to read your graph in a college level course. That's pretty ridiculous. So you need to label these well for readability. So before you start, your graph should look something like this. Labeling across the top or writing me a code and being like each tick is one is not like that's not like you're just, and this is just your warning, you'll just have a deduction on the exam, and sometimes it's not small. Okay, so then I'm going to put these on. So -1 and 3 and 0 3/4 right there. Okay, and then 5 4/3 is my max, and 4/3 is a little bit over 1. Oops. So I'm going to make a little cap there. And then 6.5, 6.5, 1.3. I must just, right, that's barely below this point at 5. It's right there. Oh, okay. So it's below, but it's barely. I don't know what's happening. Come on, draw a little dot. Okay. And this is my point of inflection. Oh, good. And then because I'm looking at this and I'm like, how is this connected? But I forgot my asymptote. So I'm going to put those in. 2 has this vertical asymptote, right? And then I have this horizontal asymptote at 1, which is only about long-term behavior. So this piece where like it definitely looks like I've crossed my horizontal asymptote, that is completely fine. Oh, I forgot to get the limits on either side of these asymptotes. Do you see that? Oh, and look here. Okay, hold on. I see a couple things. So, like, I'm just looking at it to see if this picture makes sense. And right here, this one, I don't know if you're yelling at me while watching this. This looks weird to me because I'm like, how is this going to, like, line up with these asymptotes? And it's because this should be -3/4. Hold on, I'm going to erase this. I'm erasing indiscriminately. Let me draw back my y-axis. But it's -3/4. Okay, so, okay, now, like, I feel better. Okay, but I do need to find these limits on either side of the line equal to 2. So let me go back up there because I forgot to do that work. Because right now I have no idea what's happening around this vertical asymptote. So where was that? Right here. I'm going to do this. So I need to find the limit as x goes to 2 from the left of f of x, and the limit as x goes to 2 from the right of f of x. And if you remember, this is like a sign analysis on f of x. So I'm just going to look again at this f of x, and so just to the left of 2, a little bit less than 2, I'll get, for my f of x, I'll get like a positive. I'm going to think about this. Because I know this is going to infinity or minus infinity, I just need to figure out what the sign is. So to the left of 2, I have a positive and then a negative. And then something to the left of 2 is, oh, the bottom is always positive. So I think this is going to negative infinity. So I'm going to draw an arrow, minus infinity. Oh, I'm going off the page. Okay, so this is the limit as x goes to 2 from the right, and that is going to be positive and also still negative. And then still positive. So this is also going to negative infinity. Is that possible? Both going to negative infinity? Let me look at my picture again and see if that makes sense. And let me see about this increasing, decreasing stuff, because that should line up. So it looks like it does, and I think I should be increasing in between here 2 to 5. So in here, I should be increasing, and this entire time from minus infinity to 2, I should be decreasing. So I think this looks like this. Probably goes through these 2 points, and then as I go this way, I'm going towards minus infinity. That's an arrow. Okay. And then again, towards minus infinity on this other side. I have to redraw this. You can't cross the vertical asymptote. Okay. Then it comes up, I'm concave down right here until I get to here, and then it'll turn to concave up, so it's kind of like that. There's a turn in here. That was rough. Okay, so concave down, concave up out here. I might redraw this piece a little bit. Hold on. So right in here, I'm gonna, but I'm unsure of this. So right there, that's concave down, and right here, I'm gonna turn, but I don't want to really cross. I mean, I don't really know if this crosses the this line at x equal to 1 again, or slides around along the top of it, but there's like a small kind of change in concavity there. Okay. I think that should be the graph.